All right, welcome to it. Lily is saving up money to buy a new basketball hoop. Good for you, Lily. She already has $20 and she needs $300. She earns $7 per hour babysitting her cousin Olivia. Create an equation and solve it to find how many hours she must babysit to buy the hoop. First of all, I know the cousin Olivia here. She doesn't need to be babysat. But anyway, earn your money. The equation, of course, will have an equal sign. And then there's couple ingredients they give us here. She already has 20 bucks and she's going to need 300 and she's earning $7 per hour. Now, I don't know how many hours there are, so I'm going to assume that that's the variable. So $7 each hour, that's how much money she's going to have, plus the 20 that she starts with, and that's going to give you, eventually, we hope $300 to buy a new hoop, work on that jump shot. What I want to do is I want to isolate H right here. So there's a plus 20. I'm going to take away that $20, and what that does, as long as I take it on the other side, is it just leaves me with the hours that she has to babysit and the $7 that she's making. So now this is multiplication, I got to divide this by 7 to undo the multiplication. And I divide the other side by 7. So 28 divided by 7 is 4. And what this means is that, not Olivia, Lily, although Olivia could use the hoop too, Lily's going to work 40 hours in order to get the new basketball hoop. All right, solve for x. This is just your standard multi-step equation. So I'm going to show you two ways of doing this. First of all, what I could do is I could take these x's right here, since there's 3x over here, and 3x can be taken from both sides of the equation. Now, some of you might call this combining like terms. I don't refer to this as combining like terms. Combining like terms is like if there was I'm making this up, but let's say there was a 7x over here. Then I would combine 8x and 7x because they're on the same side of the equal sign. All right, so similar to the last problem, I now want to get x by itself. There's two things with x, this times 5 and this plus 2. I refer to this plus 2, and mathematicians do as well, as a constant. I'm going to take away the constant first, and I'm going to leave the coefficient until the end. The 5 is the coefficient. These cancel each other out, so you're left with 2 is the same as 5x. And again, this means to multiply, so I'm going to divide by 5 and cancel out the coefficient, and then I just have to divide by 5 on the other side of the equal sign. So as it turns out, x equals 2/5. Now you can be somewhat flexible in the way you solve this. So I'm going to show you a different way. Last time what I did is I took 3x right away. I'm going to take 4 right away this time. And I could take 2 as well. I think actually taking 2 is easier, but I want to show you that you can get negative numbers. That's okay. So 3x is the same as 8x minus 2. And now what I want to do is I want to get x by itself still. So I'm going to take these 8x's and put those on the other side, so those cancel out. And you might be saying, well, why didn't you add 2 right here? The reason for that is that I've got an x over here and an x over here now. I've got only one constant. The negative 2 is my only constant. But what I have is 2 coefficients. And in the problem before, at this point right here, I had 2 constants, and that's why I got rid of the constant. So hopefully you recognize that difference, that I have 2 coefficients, the 3 and the 8. So I take away 8x here, and you're left with 3 minus 8 is negative 5x, and that equals negative 2. We can divide by negative 5 because that will cancel out the coefficient, the multiplication, and divide by negative 5 here. So x equals negative 2 over negative 5. And since it's a negative over a negative, you can just call it a positive over a positive. And you can see the answer ultimately is going to be the same whether you take the coefficient and the variable right away, or if you prefer to take the constant right away. All right, this next one right here, I'm going to show you a common mistake. It says solve if x equals 7. What you're tempted to probably do is set this equal to 7. That's not what it's saying. It's saying imagine x right here being 7. So don't make that error. I'm writing very messy and very big here. I apologize. But all I did was rewrite this expression, and I replaced the variable x with the number 7 because it says if x equals 7. And now it's just order of operations. So I'm going to do what's in parentheses. And there are 2 operations in parentheses, addition and multiplication. So What do you think you'd do first, addition or multiplication? You should multiply if they're both in parentheses. And then I get 5 and 21s in parentheses. And so I would add those together. That's 26. And then 26 times 2. Perhaps you've played cards before, War or Go Fish or whatever. There's 52 cards in a deck. 26 hearts and diamonds, 26 clubs and spades. 26 times 2 is 52. My favorite month of the year, by the way, this is an important issue, months. I like October, that's when my birthday is, but that's not my favorite month. My favorite month, though, I love June. June is my favorite month. I just love that feeling on the last day of school where it's all over. There's nothing like it. So I show this one because I think that there's something worth showing you here for a mistake. Pause the video if you want on any of these and see if you can solve them on your own. But I take 13. This will say 2x minus 20 equals 6x. And you notice that the minus 20, this is a very common error, but negative 7 and negative 13 make negative 20. That is actually correct. What a lot of students do is call this negative 6 because they're thinking 7 minus 13, but this number isn't 7, it's negative 7. So it's negative 7 minus 13, so you're going to end up with negative 20. That's something that you're going to do wrong a lot if you're not careful. Subtract 2x. Again, we have a coefficient on both sides of the equation, so we want to put all your x's to one side or the other. So I'm left with negative 20 equals 4x. If you divide by 4, you'll end up with x equals negative 5. All right, this one right here, again, same type of mistake. I just want to show you, I'm going to do something wrong on purpose. See if you recognize my error. So I got x equals negative 6, and if I plug this in, it would say 2 times negative 6. Well, that's negative 12. And if we add 3 to negative 12, you're not going to get negative 15. You're going to get actually negative 9. So my error right here is, again, that negative 15 and negative 3, it shouldn't equal negative 12. It should equal negative 18. One more thing to show you here, distributive property. I want to show you 2 ways to solve this problem. I'm going to show you the way that you're probably most comfortable with, and then I'm going to show you the way that I actually like best. I think it's like fancy. So I'm going to distribute the 2 to the m and the 4, and that makes that 2m plus 8. And I have constants on both sides, so let me make this constant down to 10. So it's 2m equals 10, and then we can divide by 2 on both sides, and m would equal 5. The way that I really like to do this, though, I know that this means to multiply everything by 2. So if I divide everything by 2 on this side, that will actually cancel out the distributing. And then I just have to divide by 2 on this side. And when I do that, I'm left with, I haven't crossed out m plus 4, so I'm left with that on the left side. And on the right side, I'm left with 9, right? Because 18 divided by 2. So now what number plus 4 is 9? Well, that number has to be a 5. And again, I got the same answer regardless of if you distribute it or if you divide it at the beginning. But I like this because, I don't know, I think I did one extra step here. I never had to do the division that I had to do over here where I'm dividing on both sides. All I really had to do was subtract 4 on both sides, and I can do that pretty simply mentally in my head.